It's the Edexcel GCSE Maths Foundation Calculator Paper 3 from November 2023. Let's get straight into it. Question 1. Write 35% as a decimal. If we're converting percentages into decimals, all we need to do is divide by 100 because percentages are out of 100. So 35 divided by 100. The decimal point is at the end and it's going to move 2 places back before the 3. So it'd be 0.35. Question 2. Write 8,061 correct to the nearest 100. All we need to do here is find where the 100 column is, which is this 0. We look after the 0. That's telling me I need to look at the 6, which is a decider. If it's 5 or above, I'm going to give this one a shove, and if it's 4 or below, I'm going to let everything go. So because it's 5 or above, this is going to round up to 8,100. Question 3. Write down a number that is less than minus 5. So I've got minus 5 on my number line. 0 would be over here. I just need anything to the left of negative 5. So that could be negative 6 or anything smaller than that. Question 4. Here is a grid of squares. What fraction of the grid is shaded? Let's first count how many squares are shaded. We've got 1, 2, 3, 6. So altogether we have 6 that are shaded. And how many do we have altogether? We have 3, 6, 9, 12, 15, 18, and 21. So 6 out of 21 altogether. Just simplify it. You can do it on your calculator, but we just need to divide by 3 on the top and the bottom. That would become 2 over 7. Question 5. Write down the value of the 9 in the number 27.963. This 7 is my units. After the decimal point is my tenths. So this 9 is worth 9 tenths. Question 6. The pictogram shows information about the number of chocolate cakes, vanilla cakes, and lemon cakes sold by Year 7 at a school fair. 24 banana cakes were sold by Year 7. Use this information to complete the pictogram. First, we need to look at this key, and it shows us that this circle is worth 12 cakes, and it's split up into 4 equal parts. So each of these parts, if I divide this by 4, 12 divided by 4, gives me 3. So each of these is worth 3. That might be useful later. We want to fill in 24 for Year 7, so we just need 2 lots of this circle. So we're going to draw 2 circles and just split them into 4 equal parts. And that's 24. That's 12 and that's 24. At the fair, Year 8 sold a total of 150 cakes. Which year sold most cakes at the fair, Year 7 or Year 8? Show how you get your answer. So the first thing that we need to find is the total for Year 7. I'm going to count how many circles I have, how many full circles. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I've got 11 full circles. So that's 11 multiplied by 12 because each circle is worth 12. Then I've got 3, 6, 9 to add on extra. So plus 9, that'll be my answer. 11 times 12 is 132. Plus 9 is 141. So now I can compare the Year 7s with the Year 8s. 141 is smaller than 150. The 141 is my Year 7s and the 150 is my Year 8s. So the Year 7s sold less than the Year 8s. Question 7. Miklos is swimming lengths of a swimming pool. Each length of the pool is 25 meters. Miklos has swum 178 lengths of the pool. Let's first think how much has he swum altogether. So total swum is going to be the 25 meters multiplied by the 178 that he's swum so far. 25 times 178, which is 4450. He wants to swim a total distance of 8,050 meters. Calculate how many more lengths Miklos needs to swim. So we know he's already swum this amount. Let's find out how much he needs to swim still. 4,450. So we're taking away the amount that he's swum from the total that he wants to swim, and we need to divide that by the total amount of lengths because we're trying to find out how many lengths he wants. So we're doing 8,050 minus 4,450 over 25. That gives us an answer of 144. Question 8. Here are the first 4 terms of a number sequence. Explain how to work out the next number of the sequence. So you can see it's going down. How much is it going down from 97 to 91? 7 take away 1 is 6. So from there to there, we're taking away 6. From 91 to 85, again, we're taking away 6. And from 85 to 79, again, it's take away 6. So the next one would be just, again, take away 6. Work out the difference between the 5th term and the 7th term of the sequence. One way you could do this is you could continue the sequence on and you could find the 5th term and the 7th term. But because you know you're taking away 6 every single time, and there's 2 terms between these, you could just do 6 multiplied by 2, which is 12. Part C. Explain why 52 is not a number in this sequence. If we take a look at all of these numbers, what do they have in common? Just going to highlight the last digits. So we have 7, 1, 5, and 9. All of these are odd numbers. So all of the numbers in the sequence are odd. 52 is not an odd number because it ends in a 2. So we will just write 52 is an even number and all the numbers in the sequence are odd. Question 9. Mandy buys a 12-kilogram bag of dog food. Mandy's dog has 3 meals a day. She gives her dog 105 grams of dog food for each of these meals. How many complete weeks will the bag of dog food last? Show all your working. So first, let's convert this into grams because we can see we're working in grams here. How many grams are in 1 kilogram? The word kilo, if you ever see the word kilo, it just means 1,000. So you have kilometer or kilogram. So 1 kilogram is the same as 1,000 grams. So 12 kilograms, I'm multiplying by 1,000. So 12 kilograms would be 12,000 grams. If the dog is having 3 meals a day and each of the meals are 105 grams, we need to find out how much the dog is having per day. So we're going to do 105 multiplied by 3. That's telling us how much the dog will be eating per day. We're trying to find out how many weeks the dog food will last. So we're going to multiply that by 7 as well because there's 7 days in a week. So 105 multiplied by 3 multiplied by 7, or 105 times by 21 is 2,205. So every week, the dog will be eating 2,205 grams. And altogether, the bag is 12,000 grams. So we just divide this number by this number. 12,000 divided by 2,205. And this will tell us how many weeks it is. So 12,000 divided by 2,205. And we want the complete week. So we'll write this answer first, but we need to round it down. So it's 5.442. We want complete weeks. We want to write 5 as our answer. Question 10, here is a polygon. Polygon just means a shape, it just means many angles. Write down the mathematical name of this polygon. Let's count how many sides it has. 1, 2, 3, 4, and 5. That would be a pentagon. Here is a prism. Each edge of the prism has a length of 7.5 centimeters. So each of these lengths are 7.5 centimeters. The edges are just the bits that you can run your finger along. Work out the total length of the edges of the prism. Let's first think, how many edges do we have altogether? On the front, because we have a pentagon, we have 5. And on the back, it's the same, it's a pentagon, another 5. And if you take a look at all of these along the side, we have 1, 2, 3, 4, and 5. So that's another 5. So 5 add 5 add 5 gives us 15. So there's 15 edges altogether. All we need to do now is multiply this by the length of each edge. So 15 multiplied by 7.5. That's 112.5 centimeters. Question 11. There are only red counters, blue counters, and green counters in a bag. So we have red to blue to green. The number of red to blue to green is 2 to 16 to 7. What fraction of the counters in the bag are green counters? So we care about the green ones. We need to think, how many parts do we have altogether in total? So 2 add 16 is 18, and 18 add 7 is 25. So we have 25 parts in total, and 7 of them are green. So it's 7 out of 25. Question 12. A chess match lasted 3¼ hours. The match finished at 14:10. Now, what time did the chess match start? For this question, we're taking away 3¼ hours from 14:10. So what is 1/4 of 1 hour? I know 1 hour is 60 minutes, so I'm just trying to find 1/4 of 60 minutes. All I need to do here is divide by 4 times by 1. Half of 60 is 30, half of 30 is 15. So we're taking away 3 hours and 15 minutes. So it's 14:10 minus 3 hours and 15 minutes. And I can do this in my head, or I could also use my calculator. So I would type in 14 and press this button with the apostrophes. That's 14 hours. And then I would press 10 for 10 minutes and press this button again. And you can see here, it's 14 hours and 10 minutes. And that bit is the seconds. We don't need to worry about that for this. Then we're taking away 3 hours. So 3, press that button again for hours. And 15 minutes. So press that button again for minutes. And you can see the starting time was 10:55 a.m. Question 13. Simplify 8h cubed plus 14h cubed minus 2h cubed. Whenever you're collecting like terms, you're looking for the same variable, and you can see all of these are h's, and you're looking for the same power. So it's the same variable and the same power. That means you can add them or you can take them away from each other. Because they're all h cubes, all we need to do is 8 add 14, take away 2, and it's going to be that amount of h cubed. So 8 add 14 is 22, take away 2 is 20. So we have 20 lots of these h cubed. Part B, simplify 9y plus 12y divided by 3. So the first thing that I'm going to do is focus on this bracket because BidMaths tells me I need to do brackets first. Same as before, these both have y, so we can collect them together. 9 and 12 is 21, so that's 21 lots of y divided by 3. 21 divided by 3 is 7, so that's 7 lots of y. Question 14. Write the following numbers in order of size. Start with the smallest number. I've got fractions, decimals, percentages, another fraction, and another decimal. Because I've got two decimals, and I think decimals are quite easy to compare, I'm going to change them all to decimals. So I'll just rewrite these two out first, 0.558. I'll convert this one into a decimal first because I think it's the easiest. All I need to do is divide it by 100 because it's a percentage. So that would become 0.57. For these ones, I've got 7 over 12 and 6 over 11. I can just do this on my calculator. I type in 7 over 12. And you press the S to D button and it will change it to a decimal. So this one is 0.5833. And for this one, 6 over 11 is 0.5455. Now we can start comparing them. I'm going to look at all of my units and I can see all of them as zeros. So I can't use the units to compare them. Then I'll look at the tenths. All of them are 5s, so I can't compare them either. I can now start comparing them. This is an 8. That's the smallest so far. This is a 6. That's the smallest so far. That's a 7, so I ignore that. That's a 4, so that's the smallest so far, and I keep that in my head. That's a 5. So the smallest one would be this one. And I write 6/11. I use the fraction that they gave me in the question, so 6 over 11. That's that one done. Then I can continue looking at my tenths. I do the same thing again. That's an 8, that's a 6, that's the smallest so far, 7 and 5. So the smallest from those is this one, 0.558. That's an 8, that's a 6, that's a 7. So smallest out of those is this 6, so 0.56. Then it's going to be this one with a 7, and then this one with a 8, so 57%. And then 7 over 12. You could check it, you could type them all into your calculator and just see, do they get larger as you go on. Question 15. A travel agent sold 100 holidays in April, so that information is already on. Each of these holidays was in the UK or was abroad. I've split these up into UK abroad and UK abroad. 64 of the 100 holidays were sold to families, so we can put 64 in the families section, and this number is going to add up to make 100, so we can do 100 minus 64, which gives me 36 to get that number. The rest of the holidays were sold to couples. We've already found that information. 11 of the 18 holidays abroad were sold to couples. So I can put this 11 that was sold to couples, I'm going down and to abroad. Because it's out of 18, I can find out how many holidays abroad were to families. So if I do 18 take away 11, that gives me 7, and I can place that number here. Use this information to complete the frequency tree. So we've already filled in most of it, we just need to find this number. This and this would give me this, so 64 take away 7 would be 57, and 36 take away 11 would be 25. One of the holidays sold to family is chosen at random. Find the probability that this holiday was not abroad. So the first thing that I can see, this is a given question. So I'm looking for the holidays that are sold to a family. So given that it's a family. And then the second part says, find the probability that this holiday was not abroad. So I'm trying to find the holidays that are in the UK. So I'm going to first do my denominator. Because it's sold to a family, my denominator will be 64. We're choosing one of the family's holiday, and then we want the UK holidays, so we want 57. So that would be 57 out of 64. Question 16. Solve x over 7 plus 9 is equal to 4. We're trying to get this x on its own, so first thing that we need to think about, what's happening to this x. It's being divided by 7, and then we're adding 9 to it, so we need to do the opposites of that. We're going to get rid of this 9 first, so we need to do the opposites of that to both sides. So we're going to take away 9 from both sides, then we're left with x over 7 is equal to, and 4 take away 9 is negative 5. Now I've got x over 7, so I need to do the opposite of dividing by 7. I'm going to multiply by 7. So I'm times it by 7 there, that leaves me with x. And negative 5 multiplied by 7 is negative 35. You can check this, if you substitute this back into here, negative 35 divided by 7 and add 9, you would get 4. Question 17. Blake works 32 hours a week in the UK. She's paid £473 and 28p per week. Blake applies for a job in Australia. The rate of pay is 26.4 Australian dollars per hour. £1 is equal to 1.796 Australian dollars. Blake thinks the rate of pay in Australia is greater than the rate of pay in the UK. Is Blake correct? Show how you get your answer. We need to compare how much Blake is earning in Australia compared with UK. And we've been told how much Blake will be earning per hour in Australia. So let's work out how much Blake will be earning per hour in the UK. To do that, we need to take the amount that she's earning per week and divide it by the amount of hours that she's working per week, so 32. Type that in, so 473.28 divided by 32, £14.79. This is in pounds, but the job in Australia will be paying in Australian dollars. So we can't compare these right now. We need to convert these Australian dollars into pounds. I'm going to rewrite this down here. So £1 is equal to 1.796. And Australian dollars, the symbol for that is AUD. You don't need to know that, but it's just helpful to write it here. So £1 is equal to 1.796 AUD. And we know that each hour is 26.4. So we need to multiply on the right-hand side by something to get to 26.4. What have we multiplied by? So I'm going to do 26.4 divided by 1.796. That gives me 14.699. Two decimal places because I want it in pounds and pence. And now I can see how much Blake would be earning in pounds in Australia. Now I can compare these two values, this £14.69 and £14.79. So we have UK to Australia. And in the UK, it would be £14.79. And in Australia, it would be 14.69. Well, now we can compare them. UK would be paying about 10p extra. So Blake thought that Australia would be greater, but it's actually UK would be greater. So we can say Blake is incorrect as UK is greater rate of pay than Australia. Question 18. Here's a shape made from a rectangle and a triangle. So we have this rectangle and we have this triangle. The shape has exactly one line of symmetry. So it's saying if we reflected it, we'd have our line of symmetry over here. The area of the rectangle is 3.5 times the area of the triangle. So that's right, the triangle multiplied by 3.5 would give me the area of the rectangle. That'll just be useful for later. The width of the rectangle is W, and they've already put that on here. Work out the value of W, show all your working. So we've got two pieces of information that we need to find. We need to find the area of this triangle. We need to find the area of this rectangle so that we can find W. Let's first concentrate on this triangle. I can see I've got a length of 3.8 and it told me that the line of symmetry going down the middle. So this line would be 3.8 and this line would also be 3.8. And now I need to find what the base of this triangle would be so I can find out the area. If I add this line and this line and this line up, I would get 14. So to find that line, I'm going to do 14, take away 3.8, take away 3.8. So that's 14 minus 7.6, which is 6.4. So this length is 6.4 centimeters. And now I have two lengths that I need to find the area of this triangle. How do you find an area of a triangle? All you need to do is multiply the base by the height and you divide it by 2. So here, let's write it below. For the triangle, we have 6.4 multiplied by 6 divided by 2. Just going to do 6.4 times by 3, which is 19.2 centimeters squared. And we know that the rectangle is 3.5 times that. So area of the rectangle is equal to this multiplied by 3.5, which is 67.2. So now I know the area of this is 67.2 centimeters squared. I can find out what W is. How do we work out areas of rectangles? It's a bit simpler than areas of triangles. You just multiply the base by the height. So 14 multiplied by W gave me 67.2. So I just need to do 67.2 divided by the 14, which will give me W. So that's 4.8. Question 19. The front elevation of a cuboid is shown on the centimeter grid below. Let's just write the lengths of these two sides. So we have 1, 2, 3, 4. So that's a length of 4 centimeters because it's on a centimeter grid. And for the base, we have 1, 2, 3, 4, 5, 6, 7, 8. The base is 8 centimeters. The volume of the cuboid is 224 centimeters cubed. On the grid, draw the plan of the cuboid. This question has given us the front elevation, so how can we see it from the front? But we want to draw the plan. The plan is just how do you see it from above? It's a bird's eye view. It tells us the volume is 224, and we already have two of the sides, so 4 and 8. So how do we work out volumes of cuboids? All we do is multiply all of our lengths together, so length multiplied by our width by our height. And we have two of them already, the 4 and the 8. So 4 multiplied by this 8 multiplied by something else that we're trying to find is equal to 224. 4 times by 8 is 32, so 32x is equal to 224. We just need to divide by 32 on both sides to get x on its own. 224 divided by 32, which is 7. So our missing side is 7 centimeters. Now we just need to choose which of these are we going to draw on. So if you just imagine we've got a cuboid. The base is 8 centimeters, the height is 4 centimeters, and we've just figured out that this length over here, the depth, is going to be 7 centimeters. We're trying to draw the plan, so we want to see this top bird's eye view. So we need this length, and this base will be the same as that one, so we need to draw 8 centimeters and 7 centimeters. Because we've already got the length of 8 centimeters, I'm just going to put 2 dots on for 8, there, and you can see it matches up with there and there. That's already 8. And then I need to count 7 up. 1, 2, 3, 4, 5, 6, 7. So it would go up to here. Now all I need to do is draw a rectangle going through all of those points. Just label those sides, so that is 8 centimeters and that is 7 centimeters. Question 20. Write 468,000 in standard form. Whenever you're writing a number in standard form, the number needs to be greater than or equal to 1 and smaller than 10. And then you're going to multiply it by 10 to the power of something. So first, we're going to choose this number between 1 and 10. So I can see I've got 468, so I'm going to choose 4.68. Right now, my decimal point is between the 4 and the 6. I need to think how many places am I moving it to get it to the end. It's moving 1, 2, 3, 4, 5. So I'm going to write times 10 to the power of 5. Part B, write 5.037 times 10 to the negative 4 as an ordinary number. Because I've got this negative, that's telling me it's going to be a really, really small number. It's going to start with a lot of zeros. And this 4 is telling me how many zeros are going to be at the start of the number. So I'm going to have 4 zeros, 1, 2, 3, 4. I'll need my decimal point there. And then I just copy out this part, so 5037. Question 21. Here is a biased spinner. Bias just means the probabilities are not equal. You'd think because each of these look like they're taking up a quarter of the spinner, each of them have a equal probability, but it's biased, so they don't have the same probability as each other. The table shows the probabilities that when the spinner is spun, it will land on A, on B, on C, and on D. So it just gives us a table of this. Luca will spin the spinner 200 times. Work out an estimate for the number of times the spinner will land on A. Formula that we're going to be using here is expected outcome. How many times do we expect A to be landed on if we spin it 200 times? So we need the probability multiplied by the number of trials. Here, the probability of A is 0.4 and the number of trials is 200. That's the amount of times we're doing it. 200 times 0.1, dividing it by 10 is 20, and timesing it by 4 would be 80. So we expect it to land on A 80 times out of those 200. Question 22. Sajo works at a weather station. The table gives information about the temperature T at midday for each of 50 cities in the UK on Tuesday. This is a grouped frequency table because we've got values between 10 and 15 for this first row, between 15 and 20 for the second row. Calculate an estimate for the mean temperature. So this is just testing us on, can we find the mean from grouped frequency tables? Because we don't know the values between 10 and 15, we just estimate that. We use the midpoint. So we need to find the midpoints of all of these first. I'm going to write those down. So between 10 and 15 would be 12.5. And if you're not too sure, you can just find the mean of those two values. You add them up together, 10 and 15 is 25, and then you would divide it by 2. But these ones are quite obvious. Between 15 and 20 would be 17.5. Between 20 and 25, 22.5, 27.5, and 32.5. So these are the values that I'm going to use. I've got my frequency. I need to create an extra column called my fx column, which is just this value multiplied by this value, my frequency multiplied by my x value. So 12.5 times by 2 is 25. 17.5 times by 8, 140. 22.5 times by 13, 292.5. 27.5 times by 21, 577.5. And 32.5 times by 6, 195. So make sure you type in these in carefully. You don't want to make any small mistakes. You could just do it one more time just to check that you've got them all correct. Now that I've got all my fx values, we just need to think, how do we normally work out the mean? We find the total and we divide it by our frequency, how many numbers there are altogether. Here, our total will be this total of this fx column. So we need to add up all of these. Just type in these in carefully. 25, add 140, add 292.5, add 577.5, add 195. It's 1230. So we've got our total of our fx column. We need to find our total of our frequency column, but it actually tells us in the question the total of the frequency will be 50. So you don't have to work that out. Before I work it out, I'm just going to look where would an appropriate estimate for this be. I can see there's quite a few around here, these 13 and this 21. So that means my answer should be somewhere between 20 and 30. So let's take our total, which is 1,230, divide it by our frequency, the total number of cities, which is 50. Type that in, 1230 over 50, which is 24.6. That matches up with our estimate, so it looks like an appropriate answer. If you get an answer smaller than 10 or greater than 35, that means you've done something wrong. Sager says the median temperature is 22.5 because 22.5 is the middle number in the middle group. Is Sager correct? Give a reason for your answer. So Sager has thought if I take a look at all of these and I find the middle row and I find the middle of those two values, that would be my median. So that wouldn't be my median because firstly, we don't know what it would be. We don't know exactly what the values are. Secondly, if we look at all of the frequencies, there's a total of 50. So our median, because the median is in the middle position, the median would be in the 25th position. In the first row, we've had 2 so far. If we add 2 plus 8 together, we have 10 so far, so it's still not there. 10 and 13 give us 23, so it's not there. And 23 and 21 goes to 44. So our 25th value is somewhere in this range. It's between 25 and 30. So we can just write, it's not possible to give an exact median in a grouped frequency table. And we can say the median would be in, and we'll just write this down, in this group 25 and 30, so between 25 and 30. Question 23. Jenna is asked to show the inequality x is greater than -3 and less than or equal to 4 on a number line. Here is her answer. On the number line, she's put a circle at -2, but that circle needs to be at -3, so it needs to be over there. For the 4, she's put the circle in the correct place, but this is a less than or equals to. So because there's more pen on here, on the inequality, we need more pen here. That should be circled in, it should be filled in. Write down 2 mistakes Jenna has made. So the first mistake, the circle should be at -3, not -2. And the second mistake, 4 should be filled in. Part B, work out the greatest integer that satisfies the inequality. Integer just means whole number. Satisfies the inequality just means I need to solve this and find the number that works for this. So what's happening to this y in this inequality? It says 5y take away 7 is less than 16. So I just need to treat this like an equation. So what's happening to this y? It's being multiplied by 5 and then we're taking away 7. So we need to do the opposites of that. I'm going to do the opposite of taking away 7, add 7 to both sides. So I've got 5y, that -7 has disappeared, is less than, and 16 add 7 is 23. Y is being multiplied by 5, so I need to divide by 5 on both sides. So y is less than, 23 divided by 5 would be 4.6. We want the greatest number, the largest number it could be. We know y is smaller than 4.6. So what's the largest number it could be? It's going to have to be 4. Question 24. Ali buys packs of balloons and boxes of pencils. There are 30 balloons in each pack. There are 24 pencils in each box. Ali buys exactly the same number of balloons and pencils. Work out how many packs of balloons and how many boxes of pencils she could have bought. Show all your working. So with this, first thing that you need to think about, is this a highest common factor question or it's a lowest common multiple question? Because we're repeating the packs and the boxes, it's going to be a lowest common multiple question. So all we're doing is we're finding the lowest common multiple of 30 and 24. There's 3 methods you can use to find the lowest common multiple. There's listing, which is very simple. You just write out the multiples of 30 and 24. There's the Venn diagram method, and there's also the index method. So normally I would try the listing method first, and if I'm not finding it straight away, I'd probably move on to this index method. So for this one, I'm going to write out my multiples of 30 and 24, and then I'm going to find the smallest one that is in both of the lists. Let's write out the multiples of 30, so that'd be 60, 90, 120, 150, 180. I'm going to write out my multiples of 24 and I'm going to stop whenever I see one of these numbers appear. So 24, 48, 72, 96 and 120. And you can see the smallest number in both of those lists is 120. And you can just check this. If I type in alpha and this button over here where it says LCM, it creates this bracket. I'm going to type in 30, comma, so shift and this button, this right bracket, and there's a comma above it. And you can see there's a comma that's appeared there, and 24. The lowest common multiple of those is 120, and that just checks it. But you can't just do this straight away. You need to show you're working out for it. So we found our lowest common multiple, but we want to work out how many packs of balloons and pencils we need. One is our balloons. These are our pencils. This would be 1, 2, 3, 4 packs, and this would be 1, 2, 3, 4, 5 boxes. So we're going to write 4 packs of balloons and 5 boxes of pencils. Question 25. A company orders a large number of plates from a factory. It would take 30 hours, so I'm going to write hours is 30, to make all the plates using 4 machines. I'll put 4 there. How many machines are needed to make all the plates in 6 hours? So we're trying to get this 30 down to 6. Let's first think, if we had 1 machine, how long would it take? Would it be more time or less time? Because we have less amount of machines, it's going to take more time, right? So we're going to divide by 4 on the right hand side. We're not going to divide by 4 on the left hand side because it's going to take longer. We're going to multiply by 4. So 30 multiplied by 4 is 120. Whenever you do these questions, you want to find how long would it take 1 machine or 1 person to do the same amount of work. And now we can scale this down to 6 hours. So on the left hand side, to get from 120 to 6, 120 divided by 6 is divided by 20. So on the right hand side, we need to do the opposite of that. We need to multiply by 20. 1 times by 20 is 20, so it would be 20 machines. Question 26. Riley travelled by car and by aeroplane. He travelled 143 miles by car at an average speed of 50 miles per hour. Riley then travels 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total travelling time. The formula that we're going to be using here, the formula triangle, would be distance, speed and time. And here we have the distance, which is 143, and we have the speed, which is 55. So we're trying to find the time. The time here is going to be equal to the distance divided by the speed. Distance is 143 divided by 55. Type that in, 143 over 55, which is 2.6. But we need to remember that because the speed is in miles per hour, this unit is also in hours. So we need to convert this into minutes. So I'm going to times it by 60. So 2.6 times by 60, because there's 60 minutes in each hour, that's equal to 156 minutes. We know we've got 5 hours and 20 minutes, 5 hours and 20 minutes. And we need to add on this 156 minutes. So how many hours and minutes is that? There's 60 minutes in each hour, so 60, 120, that's 2 hours. And there's going to be an extra 36 minutes on. Because if I add 36 onto there, I get to there. So I'm adding 2 hours and 36 minutes. This one's quite nice because we're not going to have to carry on any hours. 20 and 36 is 56 minutes. And 5 add 2 is 7. So 7 hours and 56 minutes. Question 27. The diagram shows a solid cube placed on a horizontal table. Pressure on the table due to the cube is 3.5 newtons per centimeter squared. The force exerted by the cube on the table is 504 newtons. Show that the total surface area of the cube is less than 900 centimeters squared. First, look at this formula and think about what parts do we have. So we've been told the pressure is 3.5, and we know that the force is 504. So we're going to substitute both of these in. The pressure is 3.5 is equal to the force, which is 504, divided by the area. And I'm just going to label that as x. We just need to remember the area is just the area of one of these faces. It's the face that's touching the table, so it's that area. We need to solve this equation. Because I've got x being divided on this side, and I've just got one thing on this side, one trick that I can use is I can swap both of these values around with each other. So this 3.5 is going to appear there, and this x will appear there. So x is equal to 504 divided by 3.5, and that will give me the area of one of the faces. So 504 over 3.5, which is 144. That is in centimeter squared. The area of one of the faces is 144. I now need to show that the total surface area, so all of the area of all of the cube, is less than 900. So how many faces do we have in a cube? We have 2, 4, and 6. So 6 faces altogether. I'm going to multiply the area of one of the faces by 6. And hopefully it should give me an answer less than 900. So 144 times by 6, which is 864. And yeah, it's less than 900. So 864 is less than 900. So we've just proved that. Question 28. The line L is shown on the grid. Find an equation for L. The general form for an equation of a line is y is equal to mx plus c, where this m value is the gradient, how steep the line is, and this c value is the y-intercept. Where does it cross the y-axis? So the easy one to find is the c value because it's just where it crosses the y-axis, that's here. So c is equal to 3. To find our gradient, we can either do rise over run, but because this one's quite nice, we can just look for one across, how many does it go up or down by? So I'm going to take a look at this line. I'm going to start from here. I'm going one across. I can see it goes down by 2. So it's going to be a negative gradient. It's going to be minus 2. So my m value is going to be negative 2. I've got my c value. I just need to substitute both of these into here. So I'm swapping this m and this c with these two values. So y is equal to, we know m is -2, x plus 3. And you can check this, if you substitute a value, let's say I substitute 3 in, I should get a value of -3. Let's just check that, x is equal to 3. So I'm swapping this x out with a 3, -2 multiplied by 3 plus 3. I'm hoping it's -3, so -2 times 3 is -6, add 3 does give me -3, so that means it's correct. I could check another point as well if I wanted to. Question 29, A, B, C, and D are points on a circle such that ABCD is a square. So I've got this square and it's inside the circle. All the points are touching the edges of the circle. The square ABCD has sides of length 3.5 centimeters. So that length is 3.5 and that length is 3.5 and all of them are 3.5 because it's a square. Calculate the circumference of the circle. So we're trying to find what's the perimeter of that circle, what's the edge of that circle, how long is it. Give your answer correct to one decimal place, show all your work in. How do we normally find circumference of a circle? So cherry pie, delicious. So we need the diameter. That diameter would be going from one side of the circle to the other side of the circle. And you can see from the way that I've drawn it, what length we might need to be finding. I've got a triangle going on here, and because this is a square, that's going to be a right angle. I have this right angle triangle, I'll just redraw it. And I have two of the shorter sides, and I'm trying to find this longer side. It's the longer side because it's opposite the right angle. That's telling me I'm going to be using Pythagoras. That's a squared plus b squared is equal to c squared. Because I'm trying to find the longer side, the easy way to do this, I square these two values, I add them up together, and then I square root my answer. So I'm going to do 3.5 squared plus 3.5 squared, and square root all of that. Type all of that in. So 3.5 squared plus 3.5 squared. And all of it's being square rooted, which gives me 4.9497. So that length over here, the diameter of that circle is 4.9497. And I know circumference is pi times by diameter, so I just need to multiply this length by pi. So my circumference is my previous answer multiplied by pi. So use your previous answer and times by pi, which is equal to 15.5501. Question says it wants it rounded to one decimal place. So I'm going to look for my decimal point, draw my line there. The point after it, my hundredths, it's 5 and above. So I need to push this one up to 15.6 centimeters. That's the end of the questions for today. I'd recommend you go through all the questions, write down the topics that you struggle with before you attempt another past paper. Feel free to contact me or reach out if you need any help with anything. Otherwise, you can just check out my channel for more walkthroughs and other work solutions, including the ones from this year's set. I'll see you soon.